Hello there, I'm Hector, the creator of Iced. One of the main complaints that we get from newcomers to the library is that there is a lot of lack of documentation. And it is true, the book is completely empty currently. So if you want to learn, you have to read a bunch of code from the examples, which most of them aren't too simple. And learning by example just doesn't work for everyone. So I figured that in order to maybe improve the situation while we work on actual written documentation is for me to record a video of myself coding and building one of the examples in the repo from scratch and explaining a bit how ICE works and what my thoughts are as I code through the problem. And I have chosen a relatively complex example so that we can slowly build up and we can start from the most very basic stuff and slowly build up and making something more complicated. And what are we building, you ask? We're building a very simple text editor with syntax highlighting. You can choose the syntax highlighting theme over here. Inspired GitHub, for example, 80s Solarized Dark. You can create new files. Hello. And you can open existing files. This is the ICE README Markdown. You can see that there's a cursor indicator here, the cursor position, and the path of the current open file right there. So you want to learn how to build this? Let's do it. All right. We will start by creating a new binary crate with cargo new. We're going to name it Iced Editor because we're very original. And we're going to make it our current working directory, and we're going to start our development environment. I have recently switched from Vim to Helix, and it's been quite fun. So you should check it out if you haven't yet. Of course, we want to use Iced, so we need to add it as a dependency in the cargo toml file. Normally, here we would use the latest crates.io version, but Iced is constantly changing, and it's very likely that the code we will be writing in this video won't work in the future. Because of this, I have created a tag named text editor in the official repository so that anyone watching this video can follow along and reproduce these steps in the future. So let's use the repo URL here, https github.com iced.rs ice.git, and the tag text editor as a revision. You need to write it like that. Cool. Now let's compile the crate, and this should pull all the dependencies and Iced and compile it so that we are ready to start developing our application. Shouldn't take too long. Cool. You can see that, yeah, by default, we get the hello world message that a binary crate has. Now, let us start by making a simple hello Iced application to get familiar with the basics. We will be writing all of our code of the example in this main.rs file. The example shouldn't be too long, so we won't need any additional module structure here. All right, so how do we turn this little hello world app into an Iced application that says hello Iced? So the recommended way for newcomers to get started with Iced is to start by defining a struct for your application state. So we're going to be defining an editor struct here that is going to eventually contain all the state of the editor we're developing. This is going to contain things like the contents of the file we're editing or the file path of the file we're editing and so on. For now though, we're going to keep it empty since we just want to display some static text that says hello iced, and that's it. Then we bring the sandbox straight into scope and we implement it for the editor type for our application state. We're going to use autocomplete thanks to Rust Analyzer here. And you can see that there are a bunch of different ideas that we need to implement for eyes to work and be able to run our application. The new method is a way to initialize our state. It's basically how we tell eyes, this is the state that we want our application to be in when it starts. Currently we have no state, so we can just, pretty straightforward, just say self, and that's it. This is the title of our application. This is the title that will be displayed on the window of the application. So let's just call it a cool editor. Get it? And then the ideas that we have left are basically the core parts of what we call the Elm architecture. These are messages, update, and view logic. So messages are what we describe as events or user interactions that our application can handle or react to. For instance, a user pressing a button would be a message. A user typing some text would also be a message. Basically, it's any event that can potentially change the state of the application in some way or another. Then update is precisely where we handle these messages and change or update our application state. Finally, the view logic is where we actually produce the widgets that comprise the user interface we want to display, or elements. When the user interacts with these elements or widgets, they may produce messages described by this generic type over here, right? This is our message. And then these messages will be fed to update. The application then here in update may change as a result, and then view will be called again after update, and the resulting elements will be displayed to the user. So you have this loop of view, update, view, update, view, update, and this loop is in the end what causes the feeling of interactivity, right? It's what makes the user feel like they are actually interacting with the application and it is responding, reacting to what they're doing. All of this stuff happens behind the scenes. The eyes runtime takes care of this wiring for us, and so we can focus on building the important parts of our application. Since we're just building a simple Hello Iced app here, we don't actually have any relevant messages or interactions that we need to handle. So we can just define an empty enum as our message type and use it here. Analogously, in our update function, we can just have an empty match statement. Also, let's just remove the self here, makes things a bit nicer. Finally, in our view code is where we're gonna display the actual text, right? In this case, we want to display Hello Iced. So let's just use the text widget and just provide Hello Iced as its contents. We also need to call into here because element over here is what we call a generic widget. And normally widget functions return a specific kind of widget so that you can set attributes to it. Then finally, what you do is you turn it into a generic element, and that is something that eyes can work with. Basically, what B was saying here is you can return any element you want, any kind of widget you want. So that's how you do it. You basically can turn any specific widget into a generic widget by calling into. Message needs to implement the debug over here, and we need to import elements, and we also need to import the text widget over here. Cool. So that implements the Hello Iced app. This part here is the very minimum ice application you can build. It's an application that does nothing. It just displays text, and that's it. Now we need to run this application. How do we do that? Well, when you implement the sandbox trait, you get a run static method for free. This run method takes some settings, but we're just going to use the defaults for now. We don't really care too much about them yet. And also, running a nice application may fail. For instance, if we try to run this application in an environment without a windowing system, well, creating a window will surely fail. So run actually returns a result. And we can basically just return this result forwarded to main, and that's it. Cool. So this compiles, and we should be able to run it. There you go. Hello, iced. Okay, so now that we got the basics out of the way, we can start speeding up and getting our text editor going. So the first thing that we want to do is we want to display a multi-line text input where the user can start inputting text and editing it. It turns out that there is a built-in widget into iced that does exactly this, and it is called text editor. So what we're going to be doing is we're going to be bringing that widget into scope, and we're going to be replacing the text widget with this text editor. Now, if you look at the top right corner over there, you will see that this new text editor widget needs a reference to some text editor content. Basically, what this is telling us is that we need to add some content to our state and keep track of the text editor content in our application state. So we do that and we provide it as an argument in our view, provide a reference to it. Also, the text editor wants our message to be cloned, so let's go and just do that. Messages should generally be cloned because they represent pure data, pure events that happen in your application. There's a bunch of widgets that need that requirement. For example, a button needs it because there's a chance that you may press a button multiple times between view calls. Then of course we need to initialize the content of the text editor. In this case, we're going to initialize it to nothing. It's just going to display an empty text editor by default. Now, if we run this, we will have an actual text editor that cannot be interacted with because our update logic is actually empty if you look at it. So what we need to do is we need to actually wire the logic of the text editor with our update logic. How do we do that? Well, we use messages. And for that, widgets normally provide this idea of handlers. Handlers are these methods that take a closure that produce messages as a result. In this case, text editor exposes a onEdit handler, and it takes a closure that, given some action, produces a message. So we can go ahead and add in our message a variant that takes a text editor action, and then here we just provide this variant over here like that. And so what's going to happen is that the text editor will produce edit messages here whenever it is edited. And we're going to be getting these messages in update right here. Precisely, Rust is now telling us that we're not handling this new edit variant. So let's just do that. Let's handle the edit variant. This has an action in there. And now what we need to do here is we need to apply this action. We need to perform this action to the content of the text editor. Turns out that the content of the text editor has exactly a method that allows for this. Most widgets will just directly expose a helper, so you only need to wire things up yourself like that. And then this should already give us a fully interactive text editor. However, the problem is that the text editor will be taking the whole window. So if we try running this, you will see that it's hard to tell that there's even a text input at all. It is there, but it is actually so close to the window borders that you can't really see it. So what we're going to be doing is we're going to be wrapping it into a new widget called container. Let's actually call this input over here. And then we're going to wrap this input into a container with some padding. A container can be used to wrap other widgets, and you can add padding around them, you can center them, you can use it for alignment. It's a pretty useful widget, used for many different purposes. Now, once we do this, we will finally have our text editor working here, completely interactable. We can type, you can see the padding has been added there. Cool, so we have the basics and the foundations of our text editor. Now we just need to keep adding to here more widgets to build the example that you saw at the beginning. Okay, the next thing I want to show you is the debug view that ICE has. It can come in handy sometimes. So you may have noticed that we've stuck this debug implementation in the message type that we have here. This is because you can enable in ICE a feature called debug. And this feature, when you enable it and then run the application, you can enable, if we press F12, this debug view. This will show you some timings of things, how much time rendering is taking, how much time primitive generation, event processing, layout, view, and update. And it will also show you the last messages that your application has received here. So currently, we haven't really triggered any message, but if I press on the input here, you will see that an edit message has been received and has been processed for the click on the input, right? So if I click again, right, this is happening, right? If I type some text, you can see the message is happening, right? I just type hello there in there. If I select text, you can see that it's also dragging, right? So by this debug view can come in handy to understand what's going on in your application to some extent sometimes. It is not the most useful thing right now. That's all it does. It's also a bit cumbersome sometimes because it's over the UI and it's hard to interact with the UI while you have the debug screen. But there are some improvements coming in this regard soon. Now, I don't know about you, but my eyes are burning every time that we open the application. So let's fix that. ICE comes with two built-in themes, a dark one and a light one. By default, a sandbox will return the light theme variant of the theme enum. But we can override that by implementing the theme provided method. And we can return here the dark theme variant. Besides that, having a text editor that is empty is kind of boring. So let's initialize it with some initial content. We can use the contents of this file to initialize the editor with its own code. That sounds pretty cool. And then we can run this. And just by changing these couple lines, we should be getting a dark theme and an editor with its contents, its own code. For our next step, let's implement the cursor indicator on the bottom right corner of the editor. We can do that by creating a new position variable, and we can query the current line of the cursor and the column of the cursor by calling content cursor position over here. Then we can turn these into a text widget thanks to format, and we're going to be adding a colon between these two values. And we also need to add 1 to these values because they start at 0, but most editors display them starting as 1. Now we need to position this new indicator in our final view. Currently, we're just displaying the input here. To do that, we can use a column to display these vertically, like so. Now we need to import the missing widgets that we are using here. In fact, column is a built-in macro, so we need to import it manually. Cool, so that should work. Let's run it. Now you can see down here that we have our cursor position. It automatically updates just like that. Cool. Now we would like to push this all the way to the right side over here. To do that, we can use a row. And a row is like a column, but it positions things horizontally. For that, we will create what we would call the status bar, which is going to be the thing that's after the text input itself. We're gonna make it a row. And for now, since there's nothing on the left side, we're just gonna have some horizontal spacing there that actually fills as much space as possible. As much space is available. And then we're gonna put the position here, and that's it. And then here, we're just gonna change this to the status bar. And also, we're gonna add some spacing between the editor and the status bar, just 10 pixels or so. Now we import the widget row, and the horizontal space, and the length. And now we should see on the bottom right corner, there we have our cursor indicator, like in most editors. Cool. All right, what can we do next? Let's start loading the editor content from a file instead of embedding it in the binary here. We could use the read to string function from the standard library, but loading a file can be a slow operation. If we do it in our update logic, it could potentially block and freeze our UI for a bit. Ideally, we would like to read the content of a file in the background and be notified when the operation finishes. Luckily, the messaging system of the Elm architecture works very well for this use case. In fact, ICE has first-class support for async Rust. This means that instead of using the read to string of the standard library, we can use the Tokyo counterpart, which is async and therefore concurrent in nature. However, in order to use async, we need to upgrade our editor from a sandbox to an application. The application trait unlocks the full potential of ICE. You can think of sandbox like a simplified toy version of application. We will replace sandbox with application here, and then we will let the compiler drive us through the process. We implement application instead of sandbox here, and now we can see now that it seems that we need 3 new associated types: theme, executor, and flags. So let's add those. Yeah, theme, executor, and flags. All right. The theme type can be used to define a completely custom theme for your application. For this one, however, we will just use the built-in theme. So just type theme in there. The executor represents the engine that will be used to run asynchronous tasks in the background. ICE provides a default executor that we can use here, but basically this means that you could plug your own or implement your own executor if you want to. Flags represent any data that an application may need to be initialized. They are provided to the new method as an argument. For this application, we don't really have any relevant flags, so we can just use the unit type here. Now let's bring the executor module into scope. Cool. Now it seems that new and update have some issues. If we look at the error here, what the compiler is telling us is that new now takes a new argument. In fact, it takes the flags that we just defined, but since they're empty, we can just ignore them. Also, the compiler is saying that instead of just returning the initial state of the application in new, we also need to return some initial command. A command precisely represents an asynchronous task in ICE. It's similar to a future, but it can also encode internal actions that are only relevant for the ICE runtime. So let's add it here. A command produces a message on completion. When you return a command to the runtime, ICE will run it in the background and feed the resulting messages to update when it finishes. For now, let's just return an empty command here with command known. Let's import the command over here. And now, analogously, update also needs to return a command as well. This effectively means that we are now able to run asynchronous tasks after processing any event in our application. Let's simply return command known at the end here for now. And that's it. Awesome. We just upgraded our sandbox into an application. So we are ready now to start using asynchronous tasks. And basically we're ready to load the contents of the main.rs file over here actually at runtime instead of embedding it in the binary. So we're going to be using Tokyo. So let's actually add that as a dependency in our cargo toml file. We're going to be using the file system module of Tokyo right here, which actually needs us to enable the file system feature. So let's go ahead and do that. Cool. We're also going to add the minor version here just to be safe. Now let's go to our main.rs file, and we're going to be creating an async function that basically loads a file given a path. Basically something that we can turn into a path, and it will produce a result of the contents of the file arced, because we may be reading big files with this, and there's a chance that this result will be cloned by the ICE runtime. It shouldn't, but just to be safe, we can just arc it. Since we only need read access to the string to initialize the content of the editor, it shouldn't be a problem. Also, this is going to return an IO error kind. Let's import these things. Need the arc as well. Cool. And here we're going to be using Tokyo read to string to read the file from the path. We're going to wait for that future to finish. Then we're going to map and create an arc with the actual result when it succeeds. When it doesn't succeed, we will map the error to its kind, because we're not interested in the whole IO error. We're only interested in its kind. And we need the error to be cloned, because we're going to actually put the result, this result, in a message. That's what the command needs to, in the end, to produce. Cool. So this compiles. Now we can actually use this function we've just coded in a command to create a command that produces this result for us. So we can call load file here. We can use command perform instead of known to execute any kind of future as a command. And here we're going to pass the path. The path in this case is going to be the path to this file, but because we are running this at runtime, we need to be careful about it, because depending on the working directory that you run this executable from, we may not actually be able to load the file. So what we're going to do is we're going to use the cargo manifest there to find this file. This is an environment variable that is available during compile time. Like that. And a command also needs, as the last argument, some way to turn the result of the future into an actual message. In this case, we're going to call it file opened. And we're going to simply add a message here with the result that we just defined down there. String on IO error kind. There we go. Now, of course, update is going to complain because we need to handle this new message. So let's go do that. File opened, and we're gonna get a result here. When the result is okay, we can either do a match, or we can either do an if let. Let's go with an if let. When the result is okay, we are basically going to get the contents of the file, and we're gonna initialize the text editor content, basically replacing it with the new contents of the file right here. Cool. And now we can just initialize the content completely empty right there. And this, I think, needs an actual reference to it. Awesome. We can run this. And now this should load. We get the same result, but this is actually being loaded at runtime. Awesome. But throwing away the error here is not the best practice. So let's hold on to it in our editor state for the time being. We introduce the error kind here. And of course, we need to initialize this. We're gonna initialize it as known. And then in our update logic, we can pattern match this result right here in the actual message branch directly, and then have another for the error right there. And then when there's an error, we can just set it over here. Cool. Now we have a helper that allows us to load any file that we want from the file system very easily. We can just fire a command and load new contents for our editor. So we should be able to introduce a button in our UI that allows us to choose a file. For that, we're going to be using a library called RFD, which is Rusty File Dialogs. And it precisely has an asynchronous API that we can use. So we can easily pull this into our cargo toml and then use this async file dialog to obtain and pick a file using the native file dialog of the system. So let's go ahead and do that. Go to our cargo toml, RFD, the version is 0.12. So let's set 0.12. Let's make cargo pull this dependency. Let's go back to our main.rs file. Now here, at the end of the file, we will create a function, an async function, to pick a file. It is going to produce the same kind of result as the load file function, but instead, we're going to be creating our own error enum here so that we can unify both the load file errors and the RFD cases where maybe the user cancels or closes the file dialog. So we're going to have an error that is file dialog closed, just dialog closed. And we're also going to have the IO error file or IO just by itself. So IO error kind here, we're going to make it debug and clone as well. Now we're going to turn this into an error too. And in order to do that, we can just map the error again here. And we can just map it to error IO. Awesome. And here we're going to be using RFD, async file dialog, new. We're going to be setting the title of it to choose a file, text file. And then we're going to call pick file, and we're going to wait this. And this is going to produce basically an option with a file handle in it. And a file handle has a way for us to get a path, which is exactly what we need to call this load file function over there. So we're going to do OK or, which will allow us to turn the option into a result. If we actually have none, then it means that the user probably closed the dialog, hasn't chosen a file, so we just return dialog closed. And then we get the path here with the question mark operator. Now we call load file, path, and await this. And this needs to be a reference, I believe. Oh, it's a file handle, sorry. It's got to be just path. So let's call it handle over here. Cool. So now we have a function that we can call, put in a command, and it will let the user pick a file, and it will load this file, and then it will produce a result for us. So what we can do now is have another row on top of the input called controls. So let's define that. And here we're going to put some buttons. We're going to have a button that you can use to open a file. We're going to call it open. And then we're going to use the onPress handler to produce a message when this button is pressed. And we're going to call it open. And so we're going to just put the message over there, import the button widget. And now file opened isn't compatible anymore because we've changed the error to type. So let's actually use error here. This error also isn't working because we need to also change it. Cool. What else? And now we need to, of course, handle the new open variant of our message enum. And here's where we actually can return a command that loads or lets us pick a file, lets the user pick a file, and produces the same message as if we were just initializing the application. So the file opened message, the same one that we are using here. Of course, now we can just return command node. So let's just add command node to each one of the branches over here. Bit redundant, but very explicit. I personally like it. And that's it. So let's run this thing. And you can see that we have this open button. When we click on it, it starts a file dialog right there. For example, we can load the README of the ICE project over here, and you can see that we can actually do that. We also have a hello world in Rust right here. So this is working real well. Awesome. We can now open any file we want in our editor, but we're not really keeping track of which file we have actually opened. So let's just do that. Let's add a path field in our editor state. But we have to keep in mind that when we initialize the editor, we don't actually have any path. We haven't actually loaded any file yet. Also, if we're gonna allow users to create new files, those new files won't actually have a path yet in the file system. So this is hinting us that path has to actually be an option. We need to use the own version of path here, pathbuff. So let's go ahead and import that one. We initialize the path as known. And now we need to just set this variable somehow. How do we do that? Well, it would be cool if these functions down here that pick files and load files would actually return together with the contents of the file, the actual path of the file that they loaded. So we can just do that. We got pathbuff to here and here. Now we're gonna also change the parameters and just ask for pathbuff directly. So that way we can get the contents over here of the file, and then we can just return the path and the contents. And here we can actually just pass a reference to the read to stream. Here we actually need to turn this path to its own version. And there we go. Now the file opened action has changed. So, well, it needs to change in order to support the new results of the async functions. So we put the path here. And now we're no longer using path anymore, apparently. Now load file needs a path buff. So what we're going to be doing here, we're going to be creating a helper for this thing. We're going to call it default file. And we're going to just create this default file. It's going to return path buff. And we're basically going to be creating a path buff from the string here. Cool. So now with this content, we are also getting a path. So we can set that path over here like so. So now we can go down here in our view and we can actually display this path that we have. So let's actually create a new variable called file path. We're gonna match in the path that we have. We're gonna deref it and map it to a path to string. Because turning a path into a string can actually fail for OS reasons, shenanigans. So we are not going to really kind of care about weird paths for now, just for the sake of the example. And then we're going to return some text here with the path. Let's actually set the size of the text to 14 or something like that, so it's not too big. And if we don't have a path, then let's just return just empty text. Now we need to import this, so let's do it. And here, yeah, we are actually mapping, and we should be using onThen. Cool. Now we need to put the file path over here. The error here is that Rust cannot really figure out the message of the text widget here. But now we can, because we are just introducing it in the actual UI. Cool, so now we do that. We should see the path right here. Cool, and if I load a different file, the path changes as expected. Awesome. Okay, we should already be getting quite familiar with how ICE works. So let's implement a bunch of more interactions. One of the interactions that we want to implement is the idea of creating a new file. So let's add this new message over here and see what happens. All right, we have to go to update and fix this compiler error, which means we need to handle this message. So let's say that we have already displayed a button with this new message that produces this message when you press that button. What do we want to actually do? Well, we look at our state. If we have a file loaded, what we want to actually do is we want to set this path to nothing, right? And then we want to basically turn the content into an empty content. So we want to basically replace the content with something that has nothing at all. So we can just do that very easily. Self path known, self content equals the content new, and that's it. And then we don't want to actually fire any command in this case. Cool. Now we can add a button to our controls that fires this new, and we just add a non-press handler here that produces the new message. Cool. Now if we look at here where we're handling the path of the file, when it is known, we are not producing anything. But now this case actually means that we have a new file here, so we can just show that. Also, we can group these file path and position together under the status bar variable here to make it look nicer. This way, if it ever becomes too big, we can just split it into a function helper that we can just call from here. In Iced, view code is just pure Rust. So you can use any abstraction you want to distribute or organize your view code in any shape, way, or form. You can use trades, you can use for loops, you can use iterators, anything you want. There's no magical DSL that Ice has or anything like that. It's all Rust. If you know Rust, that's all you need. We can iterate further on this file path indicator and actually match on the error that we've been holding on to for quite a while. So if we have an IO error, let's actually display some message here with the error. I think we're going to need to use as ref here so we don't consume it, although it should be copy, but whatever, let's use as ref. And let's see if we can actually turn that into a string. Yes, we can. Cool. Now this, of course, is called status. So now if there's an error, an IO error, we will be displaying the error. If not, we will display the path of the file. Cool. Now, if there's an error, we probably want to reset the error whenever the user keeps editing the file. So let's do that over here. Stop error equal no. So whenever you're editing, the error will be reset. All right. What else? We can actually start adding our save functionality. So let's go forward and create a save interaction over here. Yeah, sometimes Rust Analyzer likes to import the process command on its own. I have to disable the auto imports. They don't work very well. So we have new, we have open, we're going to have save as well over here. And now what we need to do in this case, we need to get the content of the editor. So we can do that. Let's actually just call it text. Why not? Then we need to perform a command that we haven't yet. Yeah, I think Rust Analyzer just introduced it again. Yeah, thank you very much. We need to implement a command. We need to implement an async action that saves this text in our path, basically. And our path can be an option. So in the case that the path is known, we will have to actually select a file. And then we will produce a file saved result of some sort over here. File saved. Let's keep file open close to the open interaction. And here we will produce an empty result and an error. Because, yeah, saving a file doesn't actually produce much. Cool. Now, whenever we save, let's move this up here. Whenever we save, we will be getting a result over here that we don't actually care about much. So we will just do nothing in this case. In the case there's an error, we're just going to be setting the error over here. And then producing command no. Cool. Now we're missing the save file method or function, and let's create it. Save file. We're going to be passing an option, pathbuff, and some text that we need to save. And we're going to be producing a result out of that. Now, if we have an actual path, then we just want to keep that path. So there's path over here. If we don't have a path, then we need to pick it. We need to let the user pick a path. So we're going to be using RFD file dialog. We're going to create dialog over here. We're going to title it choose a file name. We're going to be awaiting for that. Wait, we need to save file first, then we await. Now this will produce an option of a file handle. So we're going to be turning this into an error dialog closed in the case the option is known. Now we have a result. So we have to basically map the result to a pathbuf somehow. So we need to turn it into a pathbuf here. We can do that by mapping the actual file handle to a path and then to owned like that, and then using the question mark operator to short circuit. Okay, now we can use Tokyo FS write and use the path here and the contents to write the file. Now we await here and we map the error into the error IO error kind over here, and that should be it. Oh, it's text. Cool. Let's actually rename this to IO failed, because I feel it's more consistent to, since we have dialog closed, it should be IO failed. Now we can, if you think about it though, when we actually save a file, we can actually be saving a file that is a new file. So we should be setting the path in that case. So I think that save file should return a pathbuf as well. Should return the path in the end. So we can just do that. Short circuit here so that it produces the error, and now it produces a pathbuf over here. This needs to be IO fails, and over here we need to actually get a pathbuf. Cool. So now we're getting a path here that we can set. And then here we need to clone this path in order to pass it to the future. Because futures that you return in iced commands need to be static. They cannot borrow from the application state. Awesome. So we've implemented a bunch of stuff this time around. So let's run this thing, see if it works, or we messed up somewhere. Right? We have the buttons. First issue that we see is that they're all crammed together, so we need to add some spacing over there. We press new. Cool. It starts, it resets the content, and it starts a new file. Let's write something. Hello. Now let's press save. And nice, it starts this choose a file name. We can go, I don't know, right here and say hello txt, save it. Cool. Now we can try opening something else. It opens it, it shows the path, opens it here. Nice. Everything seems to be working. Okay, so let's go real quick to our view and fix the spacing between the buttons by introducing 10 pixels of spacing between them. And I think that something we can do is we can replace the labels of these buttons with some actual icons. Icons and loading fonts and eyes is one of the main pain points that a lot of newcomers have, so I want to address that in this video. A tool that I really like to use is called Fontello for this. It allows you to generate custom fonts with specific icons that you want. In this case, we're going to be picking the file icon. You're going to be picking a file icon, a floppy icon, and the pick folder icon or whatever. Now, before you download the font, it's very important that you give it a name. In this case, we're going to call it iced or editor icons, for example. This name is the name that you will need to use when you refer to the font in iced. So we download the font, we go back over here, and we're going to be creating a fonts directory. We're going to be moving the font that we just downloaded into our fonts directory. We're going to be unzipping it. And the font that we are actually, the file that we care about is the TTF file. So we are going to simply move that file over here, and we're going to remove that directory because we don't care about anything else. So let's remove the zip file as well. And there we go. We have our editor icons TTF. That's all we care about. Now let's load this font in iced. We can do that by providing an additional field to our default settings over here. Until now, we've been using the default settings. We can provide a bank of fonts over here. We can provide a list of fonts that will be loaded by default when the application starts. This takes a list of counts of slices. So these are the font bytes. We can basically include the font, embed the font in the binary with this. We called it editor icons, right? And then this is gonna say that, well, this is an actual static slice of bytes. So we need to, well, it's not even a slice, it's a reference to a actual size array. So we turn it into a slice and then we turn it into a cow, and that should work. Cool, so now we're loading this font. ICE is gonna load this font at startup, and we can refer to it by using this name, editor icons. So what we're gonna be doing down here, we're gonna be creating this icon helper. We're gonna be passing a code point. It's gonna be a character, which is gonna be this codes over here. These are the codes of the icons that we need to use. These are the unique code points. And we're gonna be passing these values over here, and we're gonna be using that font to refer to these icons. So this is gonna be producing an element in the end with some message that is going to be, all of this is going to actually be generic. So we implement this as we need a font. So we're gonna call it icon font. We're gonna make it a constant. We're gonna use with name here, and we're gonna call it editor icons, of course. Now we need to import font over here. Nice. Now we're gonna be using text. We're gonna be passing the code point, and we're gonna be setting the font to the icon font, like that. Now we need to turn this into an element, and of course this needs to be in a lifetime name. Cool. Now we're gonna use this function. We're gonna be creating a helper for each of the icons that we need. So we need one helper for a new icon, or the new file icon. This will produce an element as well. We need these. Actually, the message we can completely ignore. We don't need the generic because we only have a single message in this application, so we can just use that type directly here. So we're going to be calling icon, and we're going to be providing the Unicode code point over here. If I'm not wrong, this has to be U like that, and then E800. Yeah, that's correct. Now we're going to be implementing two of these as well. One for the save icon and another for the open icon. Actually, let's put the open first. Open is F115, so let's change that F115, and the save icon is E801. Cool. So now we should be able to use these for our button instead of the labels that we have here, because a button takes any element you want. In this case, we're passing a string slice directly, but the trick here is that a string slice can be turned into an element, and you can see here that button takes actually an into element. So that's a nice trick. You can pass a string and it will be automatically turned into a text element for a button, but a button can contain anything you want. So for the new, we're going to just be passing the new icon, and over here we're going to be passing the open icon, and over here we're going to be passing the save icon. Awesome. Will this work? Let's try it out. Hopefully it does. Yes, there you go. Our icons are right there. You probably noticed that the icons have different sizes and the buttons are sized differently. So what we can actually do is we can create a helper for these kinds of buttons called action. Let's do so. We're going to create an action helper or a function called action. And we're going to be passing the icon and we're going to be passing the message as well. So we can just call this way and we can create buttons in a way that is controlled. So all of them look the same. So let's go where we define our icon function and we're going to be creating a action over here. And this function takes some content, which is going to be an element, message A. They're going to be providing an onPress message as well over there. And we're going to be producing another element. So as you can see, you can use Rust in any shape, way, or form you want to organize your view code and to create helpers, right, and reuse logic. So here we're going to create a button with the content and the onPress with the onPress. Now we want all the buttons to look the same. So what we're going to do is we're going to wrap the icon or the content into a container. Here we're going to give it some width, like 30 pixels or something like that. We're also going to be giving the buttons some padding. You can use an array here and we can provide the horizontal padding and the top padding. So for example, like that, 510. And that should work out. We need to turn this into an element. And I think this should provide us with a uniform sizing for the buttons. Cool. Now the problem is they're not centered. So let's quickly do that. Our container here has a width of 30. In order to center, you can just use center X. Simple. Nice. Now our buttons and our icons have the same size and they're perfectly centered. Awesome. But let's go even a bit further. Wouldn't it be cool if we could show a tooltip when you hover the button and it actually tells you what the button is going to do, like new file or open file or save file? That'd be pretty cool. Could we actually do that? Let's do it. Let's provide a label here or some kind of thing like that with a string. It's going to be static in this case. We're going to be using the tooltip widget over here. This is a built-in widget that ICE has, and it can be used to display anything you want in a tooltip. So there are 2 arguments missing for tooltip. I think that the second one is the actual label, and the third one is the position. So in this case, I want the tooltip to follow the cursor. Of course, we have to move onPress here because that is a method on the button, not on the tooltip. Padding as well. Nice. Okay, so now this should actually show a tooltip. Let's go over here and we need to provide the actual label over here, new file. We're going to be providing open file. And here, save file. Cool. Let's try this out. Now you can see that the text is there, the tooltip is appearing. However, it's just the text, right? It'd be cool if it had an actual box or a background or whatever. It's kind of hard to read. We can do that with styling. In order to add styling, we need to import iTheme, and we will go to our action function and we will add some style to the tooltip. In this particular case, the tooltip takes a theme container. This is the styling that the theme supports. So basically the built-in theme supports a certain different variations for every widget that you can use built-in by default. In this case, a container can be turned into a box. So a box will, basically a container that is a box has some background to it. So if we run this now, the tooltips should have a background instead of just being text, right? So now they're easier to read. Let's introduce syntax highlighting, the cherry on top. First thing, let's set the default font to a monospace font. We can do that by setting this setting over here. Then, in order to implement syntax highlighting, Iced already comes with that built in for you if you want. So we can go in our cargo toml and we can enable the highlighter feature over here. Now let's pull that. It's going to pull up on a couple dependencies. The syntax highlighting is built on top of Syntact, the Syntact crate, and it is very much work in progress, but it kind of works, so it's pretty cool. Now, when you enable this feature, you can basically import in Iced the highlighter module together with the highlighter type over here. We can enable syntax highlighting by going to our text input over here and calling the highlight method on it. We need to provide an actual highlighter type over here because the highlighter strategy is actually generic for a text editor. You can implement your own if you want to only highlight specific words, or you don't want to incur the overhead of actual proper code syntax highlighting that the built-in highlighter that Iced provides has. The arguments of this function are mainly some highlighter settings over here, and then a function pointer that turns a highlight, which is the output of a highlighter, together with a theme into some text format. Text format is the font and the color of the text that you want. In this particular case, we're not going to be using the theme for anything. We're just going to be directly turning the highlight into some formatting, because the theme, we are actually going to be providing it here in the settings. As you can see, the settings take a theme and some extension. The theme, let's just hard code some highlighting theme for now. A solarized dark, for example. And the extension is, well, the extension of the file. This is used to choose the syntax of the file, or the syntax used to actually highlight the file. In this case, we can use our path to get that. We can use and then to get the path over here. Then we're going to turn this path. We're going to get an extension from it. We're going to turn this into a string over there. We need to actually get a reference of this. So let's call it as ref. And then we're going to unwrap this. And we're going to, by default, choose to use the Rust syntax highlighting because, of course, why not? And then finally, we turn this into a string. Cool. So basically, take the path as a reference, get the extension, either if it has any, and if we cannot actually get anything, we actually default to Rust. So a new file, for example, will default to a Rust syntax highlighting. And that's all it takes. This should give us syntax highlighting. There you go. We have our monospace font and syntax highlighting for the file that we're currently editing in the editor. This is the code that we just wrote. Nice. Now, if we open a Markdown document, the syntax changes automatically because the extension of the file changed. And now we are actually syntax highlighting Markdown. Cool. Okay, we're almost done with our editor. It's already quite cool, but we can't really choose the theme of the syntax highlighting. So currently it's hard-coded right here. So let's change that. Let's make it possible for a user to pick the syntax highlighting theme. So we can do that by replacing this with a theme field in our state. So let's go ahead and add that. We're gonna be having here a highlighter theme. Cool. Now we need to initialize this theme of course. And we're going to initialize it to Solarize Dark, the one that we were already using. All right. And now we're going to need some way to let the user pick the theme. We can use a drop-down list for this, or a pick list, as we call it in Iced. We're going to go to View, and here we have our controls, right? So we're going to add some horizontal space to push as much as possible the list towards to the right. Again, this is the same trick as usual. Mute a comma over here. And then we're going to be calling pick list over here, right? What does a pick list need? It needs a list of options. Well, good for us, the highlighter theme exposes a constant all that contains a list of the actual options. So that's nice. All the themes that are available. Selected is the current value, like the current selected value that we currently have. So this is just the theme that we have in our state. And then we need, of course, some way to react to this. What happens when the user selects an item on the list? So we use a closure, or we use a message for this. So we say theme selected. Now, of course, this message doesn't exist, so let's just add it over here. Theme selected. And it takes basically a highlighter theme over here. Now, update is gonna complain, so let's handle the message, of course. And we get a new theme over here, and then we just set the theme like that and return nothing. And that's it. That should be it. We have a picker list for this. We should be able to run it. And there you go. This is it, the pick list. You can see that these are the built-in themes that are supported by default by the highlighter in Iced. We can change just by clicking on them. 80s and Inspired GitHub. Now, one of the problems is that the Inspired GitHub theme is a bit unreadable. This is because this theme isn't really made for a dark background. So what we can actually do is we can go to our theme over here, and we can actually check if the selected theme is dark. And if it is, then we return the dark theme of Iced, and if not, we are going to return the light theme. And with this little change, when we select the Inspired GitHub theme now, Iced will change to the light theme as well. So now everything is way more readable. Cool. And if we select another one, it will stay on the dark theme. There's one more thing I want to show you before I finish this video. But in order to show you that, we need to implement a way to track whether there's been any changes to the current document, so that we can disable the save button in that case. So we're going to introduce this dirty field in the editor. Now we initialize this flag as true because if we have a new file, it hasn't really been saved yet. So you should be able to save an empty file if you want to. Now, whenever there's an addition, we need to set this flag, if it hasn't been already set, only if the action is actually some kind of edit. If you're just clicking on the input, that shouldn't trigger as a dirty, it shouldn't trigger the dirty flag. The reason why I'm placing this logic up here is because this will consume the action. This will move the action over here. And so we won't be able to actually call isEdit over here. So let's move it up there. Now, whenever a file is saved, right, and it's saved successfully, we can just set isDirty to false. Cool. Now, what we want to do is we want to disable this button if the flag isDirty is false, right? So we can do that by passing here only the message if the flag is set true. So you can do this with then sum like that. Now the problem is that this of course takes a message, but let's change all these to actually take an option. Now we go to the definition of action and we change the onPress to an option over here. Of course, this won't work, but the button has an actual onPress maybe helper that does exactly what we want. Now, to make it even more apparent, we're going to actually change the style of the button if it's disabled. So let's have a flag is disabled over here, onPress is known, because we're going to be moving it over here. And if it's disabled, we want to use a secondary button. And if it's not disabled, we will just use the primary button styling. Now we can run this. And wait, we forgot to set the is_dirty flag to false when the file is recently loaded. So let's go there, file opened, self is_dirty equal false over here. Also, if we create a new file, we should set the dirty flag to true. So let's see if this works now. Yep, button disabled. I press new file and I can save now. Cool. So what I wanted to show you with this is that now we can implement a shortcut for saving the file. Basically, how do you listen to external things that happen in Iced? So far we are reacting to things that we are causing or the user is causing. But it is not clear how we would listen, for example, to a keyboard event. So Iced exposes this idea called subscriptions. And a subscription is some way to listen to something that has happened externally. In order to use a subscription, we basically implement the subscription method. Let's place it over here. And a subscription method just returns a subscription type. We can import this type over here. And what we're going to be using is the keyboard module of Iced. And the keyboard module has a onKey press function over here. And you can see here that onKey press takes a function pointer that, given a key code and some modifiers, some keyboard modifiers, produces a message. Maybe. If you produce known, then this subscription won't actually do anything. But if you produce a message, it will actually be fed in update. So what we can actually do here is we can listen to key presses and produce messages as a result. So we have a key code over here and we have some modifiers. And what we actually want to do is we want to match on the key code. Then we want to see if the key matches S, and then the user is pressing command at the same time. What we're going to do is we're going to produce a save message. So we're basically going to simulate the user clicking on the button, on the save button. If none of this happens, then we don't actually do anything. And that's it. We're going to actually produce a message whenever the user types Ctrl+S on Linux or Windows or Command+S on macOS. That's what command means. Let's run this. So for example, let's add a comment over here. Let's see if it works. Now I'm going to press Ctrl+S. This should disable. Yep, it works. Let's see if I can actually reload the file over here. There you go, the comment over there. Awesome. So this concludes this video tutorial. I think it's already long enough. It's been fun doing it. I hope you enjoyed it, and maybe I will do it again for other examples. I think this was quite exhaustive and touches a bunch of things: subscription, commands, theming a bit, and well, hopefully this helps a bit to deal with the lack of documentation that the library has. Thanks for watching.